Let's have a quick check on what is machine learning. In the previous slide, we have seen machine learning being a technique in which computer can learn from data without using a complex set of different rules. And deep learning being having this neural networks to learn from this data. So if you're adding neural networks, it becomes deep learning. So without neural networks, if you're training using a data, we can say that is falling into machine learning. So there are different techniques. So for example, this linear regression, in which basically line fitting, we can say it's part of machine learning. And KNN, which is K nearest neighbor based prediction. So I have added the links for these concepts. We can just have a quick check. Okay, so these concepts, supervised means X and Y data input and output will be provided. A network can learn based on this input and expected output. Unsupervised means only input will be provided, and based on some conditions, it can still learn from that data. Reinforcement learning means we will not be providing exactly what is output required, but we will give some score. In the sense, after completing certain steps, we will tell whether the model did a good job or not. And based on that, network will learn. That is basically reinforcement learning. Compared to in supervised giving, for each and every input, what is the expected output that we are giving, that is supervised. Here we are like for an episode, we will just tell whether it did a good job or not, or a score for that episode. And the individual steps how to be done, that information will not be available or provided, and that network will figure out itself. That is reinforcement learning. So obviously reinforcement learning will take more data and more compute to achieve accuracy compared to supervised learning. Semi-supervised is in between supervised and unsupervised. Some data will be labeled, rest of the unlabeled data will be used by the model, and basically there is this some images are labeled, so that is the way we want the behavior to be, and then network can train on unlabeled data, and with some loss functions we can still achieve, we can extract the GUs from this unlabeled data and get a better generalization. Yeah, so regarding machine learning algorithms, so basically machine learning means we are not using neural networks. Still we are having data, we have X input and output as Y, and instead of neural network we use some other method to learn this. That is what we are calling machine learning. Typically we will extract some feature, and that feature is what we will provide as input instead of raw data as input. So that is also a typical nature of machine learning. As the neural networks can learn the feature themselves, these basic algorithms, it's difficult to learn these features themselves. So that's why we have to handcraft some of the features, and that feature of the input image or input audio or input whatever it is, that feature is what will be provided as X or input to this algorithm, and expected output as Y, and this algorithm will learn to give this Y given the X. So linear regression, as we all know, is basically line fitting. Just X in this direction, Y in this direction, we just have to fit a line. So if it's a curve, we have to fit a curve. So anyway, so that is this linear regression. Then there is logistic regression. You can read about this. K nearest neighbor, as the image shows, given an input sample, if it is close to its nearest neighbors, or whoever is maximum neighbors, like whichever class, or its neighbor, maximum number of neighbors belong to a certain class, then we will assign the same class to that sample as well. It is basically n nearest neighbor method. Came in clustering, similar to this, but here we will cluster the sample points, and that is basically an unsupervised learning. We can just tell like how many clusters are required, and based on that, it will cluster the data into that many clusters, and each sample in that cluster will be assigned a particular class. And that's how K means clustering, and afterwards classification works. So similarly, there is decision tree, there is random forest, there is support vector machine. So this guy used to be one very famous or important method before this deep learning came into picture. SVM and earlier it was artificial neural networks, and because of this certain issues of artificial neural network, it was not so, it was very difficult to get any good accuracy. At that time, SVM used to be the top, one of the top method, and later artificial neural network changed into deep learning. Basically, convolution came, and that changed all the picture. And now we have transformer as well, which is doing all our chat GPT, etc. All right. Similarly, naive Bayes method also there. So these, for feature extraction, there were different methods like support vector. PCA, principal component analysis, was one of the famous methods, and there are many other feature extraction methods as well, and so those feature extraction methods plus one of these algorithms gives we can achieve certain level of accuracy for problems like image classification, audio, speech to text, etc. And even face detection, recognition, not so sure. At least for face detection, these kind of methods have been working. So yeah, so that is basically deep machine learning. And if it comes to like implementing something in very low compute, we can do it in deep learning. We have to go for machine learning. Still, many companies are doing many activities using machine learning. So this is worth studying and worth familiarizing. Also, this is really important for interviews. Still, in interviews, a lot of questions will be coming from these topics, feature extraction methods and these algorithms. So it's really worth studying. So in this tutorial, we will be going into deep learning activities. So for these, we don't need Tensorflow, Pytorch, etc. We can even do it directly in NumPy array, or there are libraries for this, so we can make use of them. All right, so let's get moving.